Remember, conic sections are those figures you get from graphing a quadratic equation. And there are 4 examples or 4 types of conic sections. First type is the circle. The second type is a parabola. The third type is an ellipse. And the fourth type is something called a hyperbola. And we're going to do an example with each one of these. So the first example is, it says find the center and radius of this figure, which is obviously a circle. We recognize that it's a circle because it has both an x squared and a y squared in the equation. Both the x and the y have exponents of 2, and the numbers in front, the coefficients of the x squared and the y squared, are both 1. They're both positive 1s in front of them. And what we do to find the center's radius is to put this in what we call standard format. And we do that by putting all the x terms together. So we'll have x squared plus 6x, and we'll leave a space. Then we'll put the y terms, which is the y squared and minus the 4y. And this negative 12, we're going to bring to the other side. We're going to add 12 to both sides because we only want the x's and the y's on this side, on the left side. Okay, and then we're going to do what's called complete the square. We're going to add another number over here to this binomial x squared plus 6x to make it a trinomial that's a perfect square. And we do that by remembering what would be in the parentheses. In the parentheses, there would be a 6. And the other number that would be in the parentheses would be half of the number for the x, half the coefficient of the x. So that would be a plus 3. There would be a square on the outside. But of course, in order for this, we need to add to this the 3 squared, the 3 times 3. We take the number that's half of this number and multiply by itself. That gives us plus 9. And of course, whatever we add on this side, we add to the other side as well. We're going to do the same thing with the y's. Here's going to be our y. So in the parentheses, is going to be a y, and half of the number in front of the y would be negative 2. This is going to be y minus 2 squared. But of course, in order for that to be, we have to add the additional number of negative 2 squared. So negative 2 times negative 2 is plus 4. So I'm adding 4 on this side. I'm again adding 4 on this side. So that ends up giving me 12 plus 9, which is 21, plus 5, which is 25. We now have put the equation in what we call standard format, where we can now read the center and the radius of the circle. How do we find the center? We look at the numbers that are inside the parentheses. Inside the with the x is a positive 3, so that'll make the x center negative 3. Inside the parentheses with the y is a negative 2, so the y x coefficient, or the y coordinate of the center, is positive 2. This is our center. So we take just the opposite signs, the numbers with the opposite sign if this would have been just a plain y squared, there would have been nothing here with the y, then what we would have done, we would just put 0. So if it's not in a parenthesis, simply because it doesn't have to be in a parenthesis because there's only a single number, that means that number would be 0. The radius is then the square root of the number on the other side, so the radius would have to be 5. So that's how we go about finding the center and radius of a circle. Is there any question about that? Okay. If there isn't, so let's then go on to the second question. Again, this information, remember all of this, you have it on this study guide that I had uploaded to your Blackboard account. It's on the information page. Okay, so this is the next thing we're talking about is a parabola. So we've talked about the circle. We're now talking about the parabola. Hopefully this thing is going to move right. Okay. So remember what a parabola looks like. A parabola is like a U shape. Sometimes it's a U shape facing up, sometimes the U is facing down. And we can right away tell if our U is going to be up or down by looking at the coefficient of the x squared, what we call the leading coefficient, the number in front of the x squared. Notice in this equation, there is an x squared, there is no y squared. The parabola is the only conic section that doesn't have both x squareds and y squareds in the equation. It only has an x squared. Sometimes it only has a y squared and a plain x, but then it would be a sideways parabola. We really didn't discuss those. But the type of parabolas we looked at are what we call opening up and opening down. Here, the A is positive, which it looks like a smile, so the number in front of the x squared is positive. Here the A is negative, it looks like a frown, so it looks like the person's in a negative mood. So you can remember it that way. This is obviously going to be a parabola that opens up because the A is obviously just 1. There is a formula for finding what's called the vertex of the parabola. The vertex is also sometimes called the turning point. It's the bottom of the U if it's an opening up U. It's the top of the U if it's an upside down U. In other words, the bottom of the valley or the top of the hill. And the way we find the vertex is by a formula that's x equals negative b over 2a. Now, this will only give us the x of the vertex. The vertex has to have not only an x, but a y, it's a point. So, but once we have the x value, we can figure out what the y is going to be. So we figure out what is the a. The a is a number in front of the x squared. Since there's no number there, it's understood to be 1. The b is the number that's in front of the x, which in this case is negative 6. This plus 8 is what we call the c. We don't actually need it to find the x value of the vertex. So what we're going to do is we're going to do x equals negative 6, that's our negative b, over 2 times 1. So that's going to give us negative, and negative gives us positive 6 over 2, which is just 3. So we know that the x value of the vertex is 3. To find the y value, to get the other coordinate of this point, the other number that we need for, because a point needs two numbers, we're going to take this 3 and put it into the original equation. So we'll get y equals, here's my 3 squared instead of the x, minus 6 times 3 plus 8. And 3 squared is 9. 6 times 3 is 18, so that's minus 18 plus 8. And 9 minus 18 is negative. You can always stick this in your calculator, remember, because you are allowed to use your calculator. 9 minus 18 is negative 9 plus 8 gives me negative 1. So the vertex is the point 3, negative 1. Well, that's how we find the vertex of a parabola. Does anybody have any questions about that? Okay, so let's just talk for a little bit about the ellipse and about the hyperbola and the type of questions we might see that have to do with those type of examples. Okay. Let's just mention what an ellipse looks like is a flattened out circle. And sometimes it's flattened horizontally and sometimes it's flattened vertically, but basically it's an oval shape. A hyperbola is two back-to-back U's. Sometimes facing, the U's are facing sideways, and sometimes they're facing up and down. They look a little bit like the shape of a parabola, but they're not exactly, it's not the same shape. And notice with a hyperbola, you're going to have two. Each hyperbola has two branches. This is one, these two back-to-back U's are one graph. Okay, so I'm going to erase some of this stuff here so I have some room. And let's take an example that has to do with an ellipse. I'm gonna put it on the board, and I'll give you a few minutes to try it on your own. And while you're doing that, I will take attendance. Okay, so it says we want to graph this ellipse. So I want you to graph this ellipse. 16x squared plus 25y squared equals 400. Okay, I want you to do a sketch of this ellipse. Because that's what they're going to give you most likely. They're going to give you an equation and try to ask you to match the graph to that equation. Okay, while you're doing that, I'm going to be taking a time. I'm going to look at the participant list, and okay. So first, I see Emma Carlton. Emma, you're here. Today is 12/12. Isis, you're here. Carly, you're here. Kayla, you're here. Zandu, you're here. Haven't seen you in a while, Zandu. I'm glad you're here. Kiana. Hi, Patrice. Sandija. And Shania. And Tahira. Rihanna. Okay. I think I have everybody now. Okay. So let's see if we can approach this now. As I said, it is an ellipse, which is this oval shape. I recognize that it's an ellipse for the fact there's both an x squared and a y squared. If the, again, remember, the only one that didn't have both x squared and y squared in it was the parabola. It has an x squared plus a y squared, but the reason it's not a circle is because there are numbers in front of the x squared and the y squared, and those two numbers are different. The coefficients of the x squared and the y squared terms are different. Sometimes we have numbers in front of them, sometimes we have the numbers are as denominators, but it doesn't matter. Those are the coefficients and they are different. Now, what we usually do is put our ellipse in what we call standard form, which looks like x squared over a squared. Notice usually we have the coefficient not next to it, but underneath it, which means the coefficient is 1 over a squared. In standard form, that's how it's written. Y squared over b squared equals 1, and we want it to equal 1. So this is the standard form of an ellipse. This is not in the standard form, but we can put it in standard form by dividing everything by the 400. Whatever number is over here, we're going to divide every term by it. It's not going to change the value of anything, it's just going to put it in a different format. Now, when I divide 400 by 16, I get 25. So that's going to give me x squared over 25. I divide 400 by 16. You could do it on your calculator. You get 25. Then I do 400 divided by 25. And that gives me 16. So that becomes y squared over 16. And of course, the 400 over the 400 is 1. If you notice, I've now taken this original equation that was not in standard form and put it in standard form. And the reason we want to do that is because we want to know what the a squared and the b squared are. The a squared is the number that's underneath the x squared. It happens to be 25, which means, of course, that means a could either be plus or minus 5. The a is the x-intercept. So there are two x-intercepts. I'm going to start graphing this now. That means the ellipse is going to cross the x-axis either at 1, 2, 3, 4, positive 5, or 1, 2, 3, 4, negative 5. There are two x-intercepts. The b squared, which is the number underneath the y squared, is 16. That gives us that b is plus or minus 4, because the square root of 16 is 4. This is your y-intercepts. So that's why it's very important to get, we can't read it originally here. It's not the number in front of the x squared. It's when it's in standard form, then the number underneath the x squared is the a squared, which gives us the x-intercept, and the number is done under the y squared gives us the y-intercept. So my y-intercepts are going to be 1, 2, 3, 4 up, and 1, 2, 3, 4 down. Now, obviously, I'm not doing a perfect graph. I'm just doing a sketch. And when you're looking at the examples, what you're looking for is it the right shape? Because they might give you two that are ellipses and two that are hyperbolas, or one that's a parabola. You look for the right shape. There might be more than one, and then you make sure it's crossing. It has the right intercepts. So this is what this ellipse should look like. Now, is there any question about that question? That is how we do the equation of an ellipse. Okay, so then they gave us another, there's another question. These are straight off of final exams. Can I erase this? No objection, I'm gonna erase it. Now with a hyperbola, I'm gonna do two examples with hyperbola. A hyperbola is going to have two branches, these two back-to-back U's that sometimes are sideways and sometimes they're up and down, which means that we will not have both x and y intercepts. We'll either just have x intercepts or just y. And you have to be very careful when you look at this. So let's say I gave you something that looks like, let's do this one. 25x squared minus 4y squared minus 100 equals 0. First of all, I want you to realize that this is a hyperbola. How do I know that it's a hyperbola? It has, first of all, it has to have an x squared and a y squared in the equation. Again, remember, the only one that doesn't have both of them is a parabola. This is not a parabola. It has both an x squared and a y squared. But what's different about this than the circle and the ellipse is the fact that between the x squared and the y squared term, there is a minus. Then not everything is positive. Either the x squared term is positive or the y squared term is positive. One is positive, one is negative. You could even have something that looks like this: y squared minus x squared equals 100. This would be a hyperbola. even though like it looks like the numbers in front of the x squared and the y squared are the same, they're not, because this is a +1 and this is a -1. So that's what makes us recognize that what we have is this graph that is called a hyperbola. There's an x squared and a y squared term in it with opposite signs, one being positive, one being negative. Okay, let's go back to this example. Sometimes they give it to us in standard form, but this is not given in standard form. Remember, our standard form means the x squared and the y squared is on one side and the numbers on the other side. So we have to first bring the 100 to the other side. So we're going to get 25x squared minus 4y squared equals 100. And just like we did with the ellipse, the standard equation for a hyperbola is x squared over a squared minus y squared over b squared equals 1. Or it might be the y squared over the b squared minus x squared over the a squared equaling 1. But again, you're going to have an x squared over a number, a y squared over a number, and it has to equal 1. Sometimes the x squared term is going to be the positive one. Sometimes the y squared number is going to be the positive one. So what we're going to do is we're going to divide everything here by 100 to get it equal to 1. And when I divide the 100 by 25, I'm going to get x squared over 4. And here the 4 into the 100 is 25, so it's going to be y squared over 25 equaling 1. And now we have our parabola in standard form. It's actually this format. This is the format where you're going to have x-intercepts, but no y-intercepts. In other words, it's going to look like this. When it's a y squared that's positive and the x squared is negative, then you're going to have these up and down parabola, and you're going to have just one y-intercepts and not x-intercepts. Why is that? Because the one that's negative will give you something y squared equals a negative number. And when you're graphing, you can only graph real numbers. You can't graph things with a square root of a negative number. That's an I. That's not graphable. So therefore, here the x squared is positive, so we're going to get a positive number for our x-intercepts. But for our y, if we tried to find y-intercepts, we'd get i's. So this is where we're going to have, what we're going to do is, so we only look at the number that's underneath the positive term. In this case, it's number underneath the x squared. The a squared is 4, which means that the a can be either plus or minus 2. Remember, the a gives us x-intercepts. So here's one x-intercept that's at 2, one is at -2, and then you can just get these back to back U shape. How wide to open them, how close, that's beyond the scope of what we teach in this course, but there is a way of figuring out more exactly how it should look. But when you're going to have to pick out the correct answer, you're going to see 2 of them are going to be going across the x, 2 of them are going to be across the y. Make sure they're crossing the right place. Make sure they're crossing at the right place. Okay, so this is an example of a graphing of a hyperbola. Okay, I'm going to give you one to try now. And see if you can do a sketch of that hyperbola. This is, again, an example that came off of a final. It gives us y squared over 49 minus x squared over 64 equals 1, and they want you to match, they want you to draw a graph of it. They want you to sketch this. So I want you to do a sketch of this. Okay, I think we can work on this together. If you notice, in this, it's obviously a hyperbola because we have an x squared and a y squared in it, and the sign in between them is minus. That makes it a hyperbola. And the one that's positive is the y, which means that we're going to have y-intercept. The x squared, if there's a minus in front of the x squared, that means the x squared would be a minus, a negative. Can't find x-intercepts. We can't solve something that has a negative x squared. And that unless, because this is it would give you x squared equaling a negative number that is imaginary. That's I. We can't do that with graphing, not with regular graphing. So we're going to have y-intercepts, and we're finding it by doing b squared. That's a number underneath the y squared is 49. Means that the b has to be either plus or minus 7. So we're going to have a hyperbola where our y-intercepts are positive 7. And when you're looking at your graph, that's what you're going to have to be looking at. 1, 2, 3, 4, 5, 6, 7. And make sure it's going up 7 and not 8, because that would look like you really have to look at these pictures. This is a positive 7 here, and it's going to -7 on the bottom. 2, 3, 4, 5, 6, 7. And then you're going to have these back-to-back U's. Now they're one facing up, one facing down, because they're crossing the y-axis. So it's not, to do a sketch of a hyperbola is not difficult if you have your equation in standard form. And remember, you're always looking either to cross the x-axis or the y-axis. So those are the 4 types of figures you can get by graphing things that have either x squared or y squared, or in many cases, as we've seen in actually 3 out of the 4 cases, we had both x squared and y squared in the equation. So if you recall, what we did is we went through graphing of what we called linear equations, which we could tell because there were no exponents on the x and the y. It was just a plain x or a plain y. 3x plus 2y equals 7. No x squareds, no y squareds, no square roots, nothing. Just plain x's and y's. That was a linear equation. It gives you a straight line. A quadratic equation could give you any one of 4 shapes depending on the way the x, what you have in terms of the squares. Okay, so I'm going to go back to now chapter 8, which is our exponential and logarithmic equations. I'm going to just finish up the topic by reviewing the last thing we did, and then I'll go through a few, we'll do a good review of the type of questions you might see that have to do with logs on your final exam. Tomorrow, Wednesday specifically, I will spend most of the time, or a good portion of the time, reviewing the one chapter that's not in the book, the trigonometry. So that's a very important review. And I'll specifically concentrate on the type of questions you have to know for your final exam. So we have at this point reviewed chapters 1 through 7 and chapter 9. We're actually doing chapter 8 now. So one of the last things we talked about on Friday was how to solve a logarithmic equation. And let's say I gave you an equation that looks like this. Let's log base 2 of x plus 2 plus log base 2 of x equals 3. I'm going to give you a few minutes to review and solve this equation. Okay. And let's work on this together now. Okay. Our general rule for solving a logarithmic equation was to go from the logarithmic form to the exponential form. Except we could only do that when it has one log on one side and a number on the other side. So when we have more than one log on a side, we have to combine or contract the log expression into a single log. And if you recall, our rule was that when you're adding logs, it means that what you were originally doing were multiplying the numbers. That's because what logs are actually are just the exponents. So the rules of logs are basically the rules of exponents. So we know when we're adding exponents, that means that we're really, when do we add exponents? When we are multiplying numbers, then we add the exponents. So if we're adding exponents or we're adding log, it means that the original numbers we were using were being multiplied. So to contract this back to a single log, we have to write this as log base 2 of x plus 2 times x. You don't add these, you multiply them, because when you're adding the log, you're multiplying the numbers, and that equals 3. So that's your first step. Get it back to a single log, contract it to one log on one side, a number on the other side. And then you can go from the logarithmic form to the exponential form. Remembering the number that's the subscript, in this case is the 2, is the base. So we're going to have a base 2. The number on the other side of the equal sign, what the log is equal to, is the exponent. The exponent is 3. So this is 2 to the 3 is x plus 2 times x. And now it's just a matter of solving this equation. If there is no base written in, it's not that it's been forgotten. It means what it's called, it is what's called a common logarithm, and it means the base is 10. So, but in this case, there was a base written in, so that's the base we use. If no base is written in, then just pencil in a 10, because that's what it means. Also, at the end of, after you've solved the equation, you have to go back and make sure that the numbers that you're using are not negative. You can't take the log of a negative number. You can only do logs of positive numbers. So you're always going to have to go back after you get your final answer and see if you have to eliminate some of the answers. Well, now let's just go ahead, and this is just a regular equation. 2 to the third is 2 times 2 times 2, which is 8. And here I'm going to remove the parentheses. It's going to give me x squared plus 2x. Which means that what I have here is a quadratic equation. Remember, we don't have logs anymore. That's a regular equation. We solve it by making it equal to 0. And I'm going to write the x squared plus 2x minus 8 equal to 0. Instead of writing the 0 first, it doesn't make a difference which way you do it. It just looks more the way we're used to seeing it. And of course, I'm going to try and factor this. This is an easier factoring because it starts with just a plain x squared, which I can break up into x and x. Remember, when the last term is negative, one of the numbers is going to be positive, one's going to be negative. And we're looking for two numbers that when they multiply, they're going to give us 8, but when we subtract them, they're going to give us 2. That has to be 4 and 2. And since the 2 is positive, it means the larger number, the 4, is going to be the positive number, and the 2 is going to be the negative number. And then you set each one of these equal to 0. So you're going to get x plus 4 equal to 0, which will give you x equal to -4. And then you'll get the x minus 2 equal to 0. That's your other one, which will give you x equal to 2. And now go back. When x is -4, this would be -4 plus 2, which would be -2. I can't use it, or I would have seen right here. You cannot do something that makes the number next to the log. The number that you want to take the exponent of has to be a positive number. This has to be eliminated. It's an extraneous root. But when x is 2, that works because everything is positive. So you only have one answer here, x equal to 2. And you have to be careful because what they're going to do when they give this as a multiple choice is they're going to give you the answer 2 and -4. And don't just grab on it because that's what you got. Remember, you have to check to make sure it's not an extraneous root. Shall I give you one more like this to try? I'll give you one that's a multiple choice question. Okay? Here's another question, a similar type question. Log 3 sorry. Log base 3 of x plus log base 3 of x minus 24 equals 4. Here's your equation, and here are the answers that they give you. Pick the right answer. I hope somebody will come up with the right answer. -3 and 27. That's 27. $53. And the last answer is, remember this last symbol means no solution. See if you can come up with the right answer on that. Okay, Ariana came up with answer B. I'm going to give you extra credit, Ariana, for that. Give everybody a couple of more minutes. Okay, a few people came up with B, so let's see if that's the correct answer. Let me see who came up with those answers. Kiana and Tahira. Let me you. So let's see if we can work this out. So again, we see we have more than one log on a side, so we have to contract it back to a single log. Again, we have this plus, so we're going to have to rewrite this as log base 3 of x times x minus 24 equals 4. That plus between the log means that what we were originally doing was multiplying. And now we can convert this from a log form to an exponential form. Our base here is 3. Our exponent is this number on the other side, which is 4. That equals x times x minus 24. And if we do 3 to the 4th, 3 times 3 times 3 times 3, that gives us 81. So 81 equals x squared minus 24x, removing the parentheses. And I'm going to get this equal to 0 because it's a quadratic equation. Very often these do turn out to be quadratic equations. I'm getting x squared minus 24x minus 81 equals 0. Now, I'm going to use a little hint. I'm looking at their answers. The numbers that they seem, they have 3 and a 27. If you notice, if you take your calculator and do 3 times 27, you do get 81. And we're looking for two numbers that when they're going to multiply, they're going to give us 81. One's going to be positive and one's going to be negative because this is a negative 81. And when we subtract them, they're going to give 24. So sometimes the answers are a hint in themselves. Instead of just starting, and what you could have done is first, well, you can't divide 81 by 2 because it's not even, but if you do 81 by 3, you right away get 27. 27 times 3 is 81, and 27 minus 3 is 24. And it's going to be a positive 3 and a negative 27, because the larger number has to be negative because our middle term is negative, which gives us that x equals, sorry, we're getting x plus 3 equaling 0, which gives us x equal to negative 3, and x minus 27 equaling 0, which gives us x equal to 27. So you might think that A is your correct answer, but remember, you could only have logs of positive numbers. If I put x to be negative 3, I can't do that. So I can't use this answer because of the negative. So only the 27 is the correct answer. And yes, everybody who answered it did give me choice B. Perfect. That was excellent. Just as a quick review of the topic that we started this chapter on. One of the things we learned how to do was solve an exponential equation. So let's say I gave you an equation that looks like this. 9 to the 7x plus 3. That's a little bit too hard. I'm sorry, I don't want to do that one. Three to the 7x plus 3 equals 27. Let's see if you remember how to solve this type of an exponential equation. Okay, let's see if we can work this out together. This is called an exponential equation because the variable, the x, is in the exponent. And what we try to do is get both sides to be written as in the same base. What do I mean written in the same base? This number is written in base 3. It's 3 to an exponent. See if you can get the other side to be written in base 3 as well. Well, yes, 27 is 3 times 3 times 3. It's 3 to the third. And then once you have both of them as the same base, you can ignore the base and just make an equation of the exponents. That means the 7x plus 3 has to equal the 3. This exponent has to equal this exponent because they're both being put on base 3. Well, then you just solve this simple equation by getting 7x, you bring the 3 to the other side is 0. And of course, when you divide by 0 by 7, your answer comes out to be 0. Mind you, 0 is a good answer. It's not no answer. It's an answer. In this case, the value for x would have to be 0 in this case. So that's how we solve an exponential equation when it's possible to get both sides to be in the same base. But let's look at a situation where you can't get them in the same base. What if I gave you something that looks like this? Five to the x equals 64. This is also an exponential equation. Now, when we try getting this exponential equation in this, let me just, I see that there's, sure there's no additional, that I'm not missing out on anybody. Good, okay. If I use the same method that I tried on the other one, since this is being written in base 5, this is 5 to some exponent, I'm going to try and get this side in base 5. So I'm going to do 5 times 5 is 25. And 25 times 5 is 125. I go right past 64. 5 times 5 is just 25. That's not big enough. 25 times 5, the next one, 5 to the third, is already 125. It is not possible to put this number 64 in base 5. That's usually what happens when you're trying to solve exponential equations. We're lucky when we're able to get them both in the same base. They both can be written in base 3, or they both can be written in base 10 or whatever. But sometimes you can't. But there is a method that can be used to solve this. But in order to do this, you must have a calculator. What you do is you put the word log in front of both of these. So you do log 5 to the x equals log 64. Now, that makes sense. If the 5 to the x equals 64, certainly the log of 5 to the x has to equal the log of 64. Now, if you notice, I didn't put a number next to the log as a subscript. In other words, the base I'm using here is base 10, because anytime you have the word log written without a subscript, it's not like the subscript was neglected or forgotten. It means that you don't have to write it in because the base is understood to be 10. It is what is called a common logarithm. It's like when you write x and you don't write 1x. Everybody knows x means there's one of them. You don't write it in. The same thing as you write log and you don't write in the base, it's understood to be 10. And the reason I want to use that base is because that is on my calculator. Every scientific calculator has what's called a log button. It's not IOG, it's LOG. Sometimes it looks like a capital level, so then it looks better. Okay. Now, what am I going to do? I'm looking at this expression, and I see that the 5 has an exponent. But if you remember what I said about exponents, when you're dealing with logs, the exponent becomes the coefficient. Because a log is an exponent, and when you have one exponent and you put another exponent there, what you're doing to the two exponents is you're multiplying. So we could rewrite this as x log 5. Remember, the exponent becomes the coefficient, equals log 64. And since I want to get what x is, I'm just going to divide out the log 5. Just like a regular equation. I want to get rid of this, so it's x times this, so I have to divide by it. I'm not subtracting, I'm dividing by it. And what I do is I go to my calculator, and I press my log button. And when I press the log button, it should come up something like this. And I put in the number 64. And I close the parentheses because that's the end of the log. And then I press divide. And then I press my log button again. And then I put in my 5. And I close my parentheses. So I'm doing the log of 64 divided by the log of 5 on my calculator. I can't do it any other way because I don't know these numbers. But when I press enter, I get a number that looks like this, 2.5840. I'm writing the whole thing I'm seeing here. 59348. What you're going to get is this, most cases, you'll get a very long decimal, probably up to 10 digits. And the question will be, either you'll see what they want you to round it off to, or they'll tell you round off. Let's say they say find to the nearest 100. So that means 2 decimal places. You want to stop here. Remember, you always look at the next digit to see if it's 5 or more. It's not. So your answer in this case would be 2.58. So we can use our calculator in a not terribly difficult calculation to figure out this exponential equation. I'm going to do one more with you, and then I think we're going to end the session here. See if I can find one.
I'm sorry, I just have a question about the final.
Yeah, sure.
What time is it again on Thursday?
It says it right there. On the
Oh, 9 to 11?
from 9 to 11.
Okay, that's good. Thank you.
Okay. And I will be, remember, your final exam is going to be on Blackboard the same way the midterm was, the same way the practice final is. You do not go on to Zoom on Thursday. You go to your Blackboard and the test will be open. Hopefully I haven't gotten the test yet, but by then I assume I will have it. So, I'll set it up so that you can have it. I'll probably open it up a little bit before 9, and it'll stay open till a little bit after 11, but basically those are the 2 hours that you're assigned for that. Okay, let me just give you, should we do one more like this? Let's do one more. Let's say I had 2 to the x equals 100. I'm going to give you a few minutes. I want the answer to the nearest 100th. That's 2 decimal places, the nearest 100th. See if you can do that. Okay, let's do this together now. So again, we have this situation where we have two to some number to x equals 100. It's an exponential equation. And if I start going, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, 64 times 2 is 128. I went from 64 to 128. I never hit 100. So I can't do this trying to put this number in base 2. So I have to do that same thing I did before. I'm going to put the word log in front of both of them, so that the exponent now will become, I can only put the exponent in front of the word log. It has to have a log there. The exponent becomes the coefficient. So this becomes x log 2 equals log 100. And then to find the x, we'll just divide by log 2 because that's what's in front of it. The x is being multiplied by. I'm just going to take my calculator. And on my calculator, I'm going to press my log button and put in 100, close the parentheses, divide, press the log button again and put in the 2 and close the parentheses. And I get 6.6438, etc. I said I wanted it to the nearest hundredth, that's being 2 decimal places. Again, the number after that second place is 3, it's less than 5, so it just becomes 6.64 is your answer. I hope some of you were able to get that. Okay, don't forget there is tutoring, in-person tutoring with Patrice today from 12 to 2 and tomorrow from 1 to 4 in room L00 in the downstairs of the Health and Technology building that's on Crown, and I think it's on the corner of Crown and Bedford. Again, most of Wednesday we'll spend reviewing trigonometry and the types of questions you're going to see from trigonometry. If you have any specific topic you'd like me to go over, make sure to bring it up on Wednesday. It's our last day before the final. Okay, any questions? Okay, then I'm going to end the session for all of us. Have a good day.